So thank you everybody for being here today. As Mindy mentioned, my name is Matthew Lowinger, and I am a product manager at Octaria, a Houston, Texas-based software development company. So the goal for today is to really kind of focus in on what type of engineering team is best for you and your company, especially as you scale up your minimum viable product, your MVP. Um, I have had a lot of experience working with a lot of different engineering teams. So really excited to share some of those experiences. Yeah. So going through our agenda today, I'm going to give a 2-second background about myself and my experience. Then the meat of the presentation today is going to be focused in on what are the different types of engineering teams, what are the pros, the cons, outcomes, etc. Then we're going to dive into some of the cost-effective engineering best practices, and then we should be good to go. So a little bit about myself. I was born and raised in Washington, D.C. area, and now I am living in Baltimore, Maryland. As Mindy mentioned, I've had the opportunity to work on, collaborate on 10 plus software products as a product owner, a product manager, a Scrum lead, and those products, they have been across a lot of different fields and industries like professional services, healthcare, e-commerce. So a lot of great experiences, and very grateful for those experiences. A little bit about the outside of 9 to 5 Matthew. I'm a big sports fan. So I have been watching a lot of the Winter Olympics and really been enjoying that. And I am also a big foodie. So if you have any recipes, especially around barbecue food, please feel free to share them afterwards. So let's dive into the meat of the presentation. So in my experience, I've seen traditionally about 4 types of engineering teams. The first one is in-house engineering teams. And by the way, when I use the word engineering teams, I think of the all-encompassing agile team. So think your developers, whether it's front end or back end or DevOps, your product management, your quality assurance, designers, technical architects, software architects. So when I use the word your engineering team, that's the all-encompassing term that I like to think through. So I just mentioned the in-house engineering team. Then you have your outsourced teams. Next, a brand new type of engineering team has been popping up, which is staff augmentation. And then lastly, your managed engineering team. So let's dive into your in-house engineering teams. So as the name implies, an in-house engineering team is really centered around your internal company team culture. They are part of your company. You know, they excuse me, they are, you know, they are part of your, you know, like the HR W-2s. What I've also seen though is that hiring an internal engineering team is extremely expensive. So I pulled a couple of salary ranges in the Mid-Atlantic region just for a comparison base. For a CTO, it's around $260,000 a year. A DevOps engineer, $115,000 a year. Front end, $100,000 a year. Back end, $100,000. Quality assurance, $80,000, and a product manager, $120,000 a year. So if you add all of that up for your internal engineering team, that's around $775,000 a year just of labor costs. So especially for a scaling startup, that cost is extremely high. And not to mention that the cost of turnover for companies is very high as well. Built in ran a survey and found that losing an employee can cost a company one and a half to two times the employee's salary. Plus, if you do lose that employee, then you have to hire and backfill for that position. And ADP estimates that hiring an employee costs around $4,100 and can typically be filled in 42 days. So call it a month and a half. So it to sum up in-house engineering teams, it is great, especially for large scale companies who have lots of funding, but especially for that niche MVP based startup. There's a very large cost of labor, and that's over $775,000 a year. So next, we're going to go into the outsource engineering method, and the term outsourcing is not new. We have been outsourcing goods and services and products for a very, very long time. And so outsource engineering is when you take your whole engineering team and you have it done through another company, but by a third party. And for a scaling startup, this is extremely cost effective because it's a lot cheaper than hiring internal, and it can also be flexible based on the ebbs and flows of your startup. So, for example, let's say that you have a software product, and there is one quarter that you really need work. You have a growing customer base. Then you can really work with the outsourced engineering team on that. However, there are at least from my experience, I've seen some of the cons for outsourced engineering teams, especially around some of the business kind of models and philosophies. So outsourced engineering teams and firms, they typically promise everything underneath the sun. Yes, we can build this feature. Yes, we can absolutely work with your very, very large budget. And also there may be some hidden costs associated to that, especially with a fixed bid contract or milestone based approach. And for a scaling startup, sometimes you only need the $10,000 Honda, but they really sell you that $60,000 Cadillac. And I think that especially for these scaling companies trying to get product market fit, starting off with a very lean MVP, of a very fractional cost is absolutely doable. But these outsourcing teams, they may try to bump up what they promise. Also, I've seen a lot of this recently, and I can think of about 4 or 5 stories off the top of my head around IP issues. So when you work with the whole engineering outsourced team, you oftentimes see that there are IP issues. Who actually owns the IP, who owns the technology? Is it the company, or is it the outsourced engineering team? And in two examples that I can think of, you actually this company spend more on legal fees trying to sort out those IP issues than the total cost of the outsourcing and outsourced engineering team. So the next model, as I mentioned earlier, this is a relatively new concept around staff augmentation. So typically outsourced engineering is the whole collective engineering team, but staff augmentation is on the individual engineer level. So let's say that you have a startup and you do have a couple of those internal team members. Maybe you have a product manager, maybe you have two other engineers. You can work with a staff augmentation firm to to add on engineers that help you scale your product. So staff augmentation is a great method for short-term holds. However, if you think about it, the long-term cost of staff augmentation can be really high because it can run up your labor cost, and also there is that opportunity cost of switching, potentially switching engineers, onboarding new team members, and really establishing that team culture, their processes. And I am also a really big fan on that team culture aspect. And I can think of a couple examples where there was a true gap between the internal team members and the staff augmentation engineers. And especially when building a product from the ground up and scaling it, you do really want to have that team culture all aligned together. So this leads me to the last model of engineering teams that I've seen, which are the managed engineering teams. And this is what and in my experience, I think that this is a great method to choose in building out your engineering team, because you have a pod of engineers. You have a product manager, you have a software architect, you have full stack engineers, you have designers, you have DevOps, and that engineering pod works extremely closely as one for the autonomous for the autonomous for the autonomous application development, for the UX product design, and for really finding that product market fit. So managed engineering teams also provide a lot of scalability, because not all companies need to hire a full-time engineering team, especially when building out an MVP and scaling it, around like the pre-seed, Series A, and even up to the Series B level. Sometimes it really only takes 20 to 30 hours or 1 or 2 sprints a month to build out your engineering team and grow out your product. So especially if we take a look at the cost compared to staff augmentation, complete outsourcing and in-house, you can have a full engineering team, of 6 different resources: your product management, your engineers, your architects, your UX UI designers, for a fractional cost. And why I also am a really big fan of the managed engineering team is that as a CEO or as a C-suite, you can really be as hands-on or hands-off as it, because you do have that trusted high-level team. Now there, especially for a very, very large company, there may be a long-term cost. However, for the scaling startup, for the MVP, Series A, and even Series B, in my experience, the best way to build software products is through managed engineering teams because of that fractional capability, because you can flex in and out resources based on your startup's need and your product needs. So now I'm going to dive into some of the kind of cost-effective engineering best practices. So especially when building out your tech stack, you have to think about how the tech stack can align with your labor costs. So for example, some of the very, very high level programming languages like C++, C Sharp, those engineers are a lot more expensive than say like a Node.js engineer. Just for a comparison, a C++ and C Sharp engineer is around $120,000 a year, whereas a Node.js engineer, and Node.js is the largest community. They have a lot of open source packages. That's around $86,000 a year. So especially for those companies kind of scaling off of the ground and just starting up, you do really want to make sure that your that your tech stack align with your labor costs. Further, you also have to think about some potential kind of tech debt in the long haul. Let's say that you start off with like a PHP backend, but a TypeScript front end. As your product scales, that could cause some potential issues, some tech debt. So what I recommend is choosing one programming language like JavaScript and sticking with it across the board. And not to mention that JavaScript engineers are a lot more cost effective than other programming languages. Now, there's this term that has been that's been coming up as of recent, and it's the no code and low code. And what that is that there are some platforms where you can actually build out a website, an application, a mobile app without really touching any code or very, very small amounts of code. So my take on no code and low code engineering is that it is absolutely awesome for that startup founder or for that startup team that is on a very, very tight budget, and they are looking to get product market fit. However, as the product scales up, you will probably have to scrap the build so that you can take into account your growth, product scalability, features, etc. So the big takeaway here is make sure that whatever tech stack that you choose, whether it's like a JavaScript, whether you use Amazon Web Services or Azure, really take note at all of the costs and see where you can save money, like an Amazon Web Services startup program, credits and things like that. So I want to wrap up today's presentation here by saying that these are the four types of methods that I've seen that I've seen engineering teams, work in. All all of these types of teams, whether it's in-house or outsourced or staff augmentation or managed engineering teams, they 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 can all work well. However, you really want to kind of tailor in on what works best for you. And in my experience, launching 10 plus products, because of that flexibility and the scalability of managed engineering teams, and especially at a fractional cost, that's definitely my recommendation and take on it. So feel free to reach out to me on LinkedIn. I have my information there, or by email, matthew@octaria.com. And I would be happy to meet and share more about managed engineering teams or some other best practices to help your individual engineering team.